Hello, this is Yannis from Any Repair. Today we'll go through a Legion y540 repair that came to our lab dead. This is a common problem for these kind of devices, notebooks, that we are familiar with and we have solved many times. Let's go and see what we did. Well, this is the board. We have already found some problems and we will share it with you. At first we have seen a broken MOSFET. On the DC in section. We will check it with a microscope for your reference. Now the DC in section is good because we have already checked and replaced this MOSFET. The MOSFET was bad, was broken. I think from a short circuit that it is further inside, and we will check it right after this MOSFET. Now we will check the MOSFET for continuity, because a broken MOSFET always beeps. You can see it is broken. We will mark as broken in order to throw it away. And now we are not having any shorts and not any MOSFET broken in the DC section, as you can see. We have no bad MOSFETs at the DC in, and not short circuit in the current sensing resistor. We're good. But let us check for coils, if any coil is shorted. Of course, we must check with diode mode and go to the 5-volt coil that is shorted, and 3 coils is not shorted. But we have already traced that the LDO section of the standby circuit, the 3 volts LDO is shorted. We will just show it to you. Here it is. This jumper is the 3 volt LDO. We have cleared this jumper, and as you can see with our multimeter, one probe to ground and the other one the LDO, we have a short. You can see it now. We have a short, and the other side is clear of shorts. So the 3 volts LDO is broken. It is usually a super IO problem, thankfully, because the other option is PCH, broken PCH. For this notebook, the broken 3 volts LDO, it is often, very often, a super IO problem. We are struggling to solder a wire and 3 volt LDO section, which is shorted, and inject some voltage to discover that Super IO is dead. I don't know why I haven't monitored the thermal camera and showed to you, but it is drawing, as you can see, 0.5 amps. 0.5 amps, which are indicating the super IO. The thermal image is not captured by the camera, by the software, but it is for sure the super IO and must be moved. So afterwards, we must check for short in the 5-volt rail. So it is short. I have already prepared the cable for soldering to the 5-volt coil. Likewise, we will voltage the 5-volt coil, which is shorting, and this time the thermal will capture the image and record it by the recording software. Now we will see that there is something heating up. This fuse or this resistance, this resist 2 ohms is heating up, but there is no such a shorted resistor. So we must find out what this resistor is feeding. As we can see, we have a low ohms value, which is good. It's 2.2, the value of the original value for this resistor. It is not altered. Usually it's going up when something is broken on the resistors. We must solder a wire there. You can see something like a hole on it. Of course we will change it, but the problem is not the hole on the resistor. We will solder a wire there and feed directly this line, not from the coil, and we will inspect our thermal image in order to find out what is heating up. Now, what is heating up? It is an IC, that is controlling the phases of the GPU. As you can see, is right under the GPU coils and must be replaced. Let's see it with isopropylic alcohol. We are trying to see the evaporation of the isopropylic. You can see it. It is heated up. The 5-volt rail that is feeding this IC is shorted. So we must remove it and see what we will have, if the short will go on or we will stay on. We have very low resistance. You can see 11 or something, very low for the 5-volt rail. So let's remove it and see. Heat gun, tweezers, heat up the chip, and the chip will be right uplifted. We will check the orientation, we will check for ohms in the 5-volt rail, which are clear from shorts. And as we can see, we have a short, the same short on the chip. So the chip is off, must be replaced. We will add some flux, and we will replace this GPU phase controller with a new one, of course. This one. We will try to align it, and afterwards we will try to keep it in place and solder it back. With heat gun and a lower pressure, because we don't want to misalign this chip or lose it. Let's go. Heat it up. That was what I was talking about. But it was close, not very far from the board, so I grabbed it again. Trying to align it. And it is self-aligned as it was soldered back. We're trying to do a better alignment. The alignment, I think it's good. We're heating up. I think we're ready. We have cleaned up. And now I think we must go and remove the Super IO. But first, we must check for sorting the 5-volt rail, as we have changed the IC. You can see that we have a very pleasant value for the 5-volt rail. And I think we are good. We can go and change the Super IO now. I've already removed the Super IO. We will clean up pads in order to solder a new one back with new solder, with fresh solder. We're cleaning up this board. We will clean up with some isopropylic in order to see what is happening. We're doing some extra cleaning, and the LDO shortage is gone. So the Super IO was guilty, and it was a right conclusion to be removed. Now we have another one from a donor. in our hands. We're trying to align it. And we will go straighten its legs because I said it is from a donor, so some legs maybe are bended. And let's go solder it. Now we will go in full speed. It's the soldering process of the Super IO. It is a lengthy job to do. We're trying to anchor some pins in order for the Super IO not to move when we're soldering the other pins on the board. We're using our soldering pen. We're often using our wick in order to remove the bridges. We're testing our pins. They're soldered. So we have already put the board back. Heatsink on. Turn out purposes. Now we will go and plug the charger. I will turn this notebook and trying not to break it. And pressing the button. Wait time. Spread. High. And now. Legion. We have a display. So we are very good. The fault is gone. If you like this video, consider like, subscribe and share. Thanks for watching. See you in another bear. Bye.